Hi class, today I'm going to explain matrix multiplication. This is in appendix A2 in page 627. Page 627. Right now, as the first case, let's discuss a simple case, a matrix with one row and another matrix with one column. A row vector which is matrix with one row like this, and matrix with one column which is a column vector like this. I'm gonna multiply these two, right? What I'm gonna do, I'm gonna multiply a row vector with a column vector. So this is what I have: the row vector 1, 2, 3, and I have column vector 4, 5, 6. So this is exactly how we multiply matrices. So let's go through this carefully. Now we multiply 1 with 4, 2 with 5, 3 with 6, and add them. We doing multiplication. I put a dot here. 1 times 4, I write 1 times 4 plus 2 times 5 plus 3 times 6. This is 4 plus 10 plus 18. This is equal to 32, right? We multiply row vector and column vector, and we end up getting answer 32, right? Now let's do two matrices with different dimensions. Now, remember the way we multiply this with this, then the second element with second element in the second row, third element with third element in this is in third row. This is first column, second column, third column, first row, second row, third row, right? Now you will see that in order to do this multiplication, there should be a number here. If there is no number, if it is 0, it's a different story. We can write 3 times 0 is 0. But if there is no number, can we perform this multiplication? We can. That means we cannot multiply these two, right? Now that means number of columns in the first matrix should be equal to the number of rows in the second matrix. What is the dimension of this, or the size? I'm gonna erase this answer. This is, remember, row times column. The size of this matrix is 1 times 3. What are the dimensions of this matrix? This is 3 by 1. 3 rows, 1 column. Now you will see that this 3 is common, means we have to have same number here in between. Then you remember the answer, we got 32. Right? Now once we can say the dimension of the resultant matrix. How? Cross this out, and then we get 1 by 1. Our resultant should be 1 by 1, and it is well agreed we get one number. Right? One number is 1 by 1. Right? Let's get a matrix with different dimensions. Say matrix A is 1, 2, 3. We want to multiply this with matrix B. Say we want to do this multiplication, and we get, say we want to multiply these two, and answer we want to write as C. Right? Now first of all, we should check if this is possible. How we check? We check the dimensions of these two matrices. Size of this is row times column 2 by 3. This is what? 3 by 2. See, this number in between is common, same number. Then how we find the dimensions of the resultant? We forget about this number in common. This is 3 by 2. We forget about this number in middle, and we should get 2 by 2 matrix. Right? So this matrix is 2 by 2. Let's say its elements are see, this multiplication should give us C1, 2. Remember the way we number these elements? Row number first, column number second. Row 1 first element C11, then second element row 1 column 2 C12, second row C21, C22. Right? Now we have to find these C11, C12, C21 and C22. Right? Now matrix C, the product between them is given by matrix C. I'm going to write C here. What we do first, we get the first row this is my first row. This is the first row of first matrix. Multiply that with first column of the second matrix. See this green line. How we find that? 1 times 7 plus 2 times 9 plus 3 times 11. Then the second element, this is our C11, right? Then the second element C12 should come here. Let me use a different color. How we get this one? This is C12. Okay. Another clue. Now we know we have to multiply this and this, but imagine just in random we won't write one of these elements, right? Out of the blue we decide to write this one. How we decide what row and what column to multiply? This tells us that C12, first row from first matrix, multiply by second column with the second matrix. First row from the first matrix, multiply by second column of the second matrix, which means this. I do it in black. This is the first row and this is the first column, I mean second column. C12, second column. First row and second column we're going to multiply. I'm gonna write that in black here. 1 times 8 plus 2 times 10 plus 3 times 12. Right. Now okay, I could have write in green this green line multiplication. I'll change it to green so you can recognize this easily. This was 1 times 7 plus 2 times 9 plus 3 times 11. Now let's use red to find this one. C21, second row, first column, second row, first column. Right. So I'm gonna multiply those two. 4 times 7 plus 5 times 9 plus 6 times 11. Now this one, what is this position? C22. C22 means second row of the first matrix, second column of the second matrix. Second row of the first matrix, second column, which is this again, of the second matrix. Multiply those two. I do it in blue. I'm gonna write it here. Four times 8 plus 5 times 10 plus 6 times 12. Right. So this gives us the resultant matrix C. Alright, so we can simplify this a little bit. I'm writing everything in one color. Seven, 2 times 9 is 18, 3 times 11, 33. If you add these together, you should get 58. And I'm gonna write these numbers. This should be 64, 139 and 154. Right. Do the math, multiply these and add them together, you get this number. Right. So the resultant matrix we get 2 by 2. The size of this matrix is 2 by 2. That's how we do the multiplication. Multiplication is very important, so go through this example one more time if you're doing this for first time, and do some other questions from homework and from the book exercises, right? Okay, let's go to now. This is the way we do any multiplication with any number of rows and any number of columns. With this, you might realize that we cannot multiply any matrix with any other matrix, right? The number of columns in the first matrix should be equal to the number of rows in the second matrix. This is 2 by 3 whenever you get matrix multiplication, first check their dimensions or sizes of the matrix. This is 3 by 2. Right, so the row column number of first matrix should equal to row number of the second matrix, otherwise you cannot do that multiplication, right? If we can do multiplication if and only if the column number of the first matrix equal to the row number of the second matrix, right? And the way we multiply, it is easy to remember this. Now once you get matrix, write this resultant in this way. This is 2 by 3, this is 3 by 2. You eliminate the number common in the middle. If it is not common, you say no, we cannot do that multiplication. If this number is common, means if the number comes in between is the same, you say okay, the resultant should be 2 by 2, right? The resultant is 2 by 2. Then write down elements in this way: C11, C12, C21, C22. That gives us a good clue about what row and what column to multiply. C11, first row from first matrix, first column from the second matrix. 1, 2. This is the row number. 2 is the column number from the second matrix, right? So go through this example one more time. So my advice is write this, and looking at this we can do this quite easily, right? After that we can simplify this. Okay, I show you how to do another example with a different size. This time matrix A is this is the question number 2 I am doing. Matrix A is 2, 1, 3, 4, negative 1, 3, 0, 2. This example is in the book page 629. 1, negative 1, 2, negative 2. B, 1, negative 1, 2, 0, 1, 1, 3, 5. First check if it is doable. We want to multiply A and B. What we do first, we check if it is doable. For that we check the sizes of these two matrices. This is 3 by 4. This is what? 4 by 2. The number that comes in middle is common, so cross that out. Our resultant should be 3 by 2. Right, then once we see the same number in middle, we say okay, yes, we can do this. 3 by 2 matrix, so let's do elements of this C11. Say this is C12, C21, C22, C31, C32. That's our resultant. Now once you get this, you know what to multiply. Let me help you to get one or two of these. How we get C11? first row of the first matrix multiplied by the first column of the second matrix. This is equal to 2 times 1, 1 times 2, plus 3 times 1, 4 times 3. Right? Find the answer. Let's find another random one. Say if you want to find random one, say this one, C32. I let you finish this example. Right? C32 means third row of the first matrix, row, this is the column, second column of the second matrix, this one, right? What we get, 1 times -1 plus -1 times 0 plus 2 times 1 plus -2 times 5, right? Find the answer, right? Likewise, find all these 6 numbers and do the matrix. That is the product between these two matrices A and B, right? Complete that. Okay, let's see what's next. Okay, identity matrix. I'm gonna erase this. Identity matrix is a matrix which has ones in the diagonal and everything else is 0. If it is a 2 by 2 identity matrix, it is 1 on diagonal, everything else is 0, 0, 0. This is what 2 by 2. Again, when we talk about identity matrix, is I said the diagonal. Diagonal is this. This is the diagonal. To get a diagonal, you should realize that it has to be a square matrix. Number of rows should be equal to number of columns. We're especially interested about those square matrices because our intention is to get involved with those systems of equations, right? Now that's another thing, but about identity matrices, their diagonal is 1, everything else is 0. Let's do another one, 3 by 3. It should have 3 rows and 3 columns. On the diagonal it is 1. Remark that everything else should be 0. This is a 3 by 3 identity matrix. Now, since it is 2 by 2, we represent this as I2 and this as 3 by 3 is I3. Right? Even here you see diagonal, it's all 1 and everything else is 0. Then inverse matrix. Once we get identity matrix, it is like identity element. If you remember, identity element means identity element with multiplication is 1, means 1 times anything is the same thing. 1 times 5 equal to 5. Also we know 5 times 1 equal to 1. Here 1 is called identity element. In case of matrices, we have something similar to this identity matrix. The meaning is the same, that identity element times the matrix gives us the same matrix. The difference is we in multiplication between numbers, identity element is always 1. So it's the same. But with matrices, this identity matrix different from matrix to matrix. For one matrix, for 2 by 2 matrix, identity matrix is this. For 3 by 3 matrix, identity matrix is this. Right? Now, okay, I'm gonna erase this. Inverse matrix. Okay. Now, inverse matrix means when we multiply matrix, inverse matrix, first of all we write it as A inverse. Right? It is a matrix that when we multiply matrix A with its inverse, or when we multiply inverse of the matrix with its matrix A, it should give identity matrix. Right? Identity matrix. Now, in case of number, if you multiply 5 with 1 over 5, this is same as 1 over 5 multiply with 5, we get 1, right? That's the similarity. The difference is with numbers, identity element and the multiplication is always 1. With matrices, this I depend on the size of the matrix we're considering, right? Now let's see an example. Now here let's learn how to find the inverse of 2 by 2 matrix, right? I'm gonna erase this. Let me erase this line and show you an example. Now inverse of matrix A, this is for 2 by 2 matrix. Matrix say A inverse is equal to 1 over absolute value of the determinant of matrix det A. In short, I'm gonna tell you what this det A, and we interchange. Let's get an example. Means say this is A, B, C, D times here we interchange these two, A and D. We write D here, A here, and we change signs of these two, negative C and negative B, right? Understand? Now you may use this as a formula to find inverse of matrix 2 by 2 matrix. Now let's get an example. A is here, A inverse is here, right? Let me find a simple example to do first. Okay. 2, 1, 1, 1. A is equal to 2, 1, 1, 1. Right? Find A inverse. Okay. Before I do that, I said I'm gonna tell you how to find this determinant of A. When you find det A, determinant of A is equal to, you multiply these two, AD. You may remember in this way, when you multiply downwards it is positive and upwards it is negative. This way it is negative. Right? AD minus CD or BC. CB. Okay, downwards it's positive, upwards it is negative. I write like this, positive, and this is, when we multiply upward, this is negative. Right? AD minus CB or BC, same thing. That's it. That's all about determinant. Now we're gonna use this for this example. A inverse is what? A inverse is equal to 1 over determinant A times we interchange these two, 1, 2, and we change signs of these two, negative 1, negative 1. Right? Determinant of this matrix, 1 over downward 2, positive 2, upwards negative 1, 1, negative 1, negative 1, 2. Right, I'm gonna erase this. We apply this equation. If it is unclear, I'm gonna write that again. 1 over 2 minus 1, 2 minus 1, two minus 1 is 1, 1 over 1 is 1. We don't have to write that. Here we get 1 minus 1, negative 1, 2. Right? Okay, this is our A inverse. Clear? Now this is our A inverse. We found A inverse. Now how do we know if this is correct or if this is the right answer? We can use the check. We can check if A inverse A equal to I. Right? Let's do this check. For that, I'm gonna keep this A and A inverse. When we multiply them, we should get identity matrix. Now, this is the answer. This question is finished. This is the final answer. We found A minus A inverse. Now we're going to check. Right? We have A inverse. I'm gonna write this answer here and erase this. Erase this. Now what we're going to do, we want to check. For that, what we're checking if A inverse A or A inverse, both the same, A inverse A inverse equal to I. If you check one of these, that's good enough. So let's multiply A inverse A. I let you multiply A in A and A inverse by yourself. I'm doing A inverse times A. We get 1, negative 1, negative 1, 2. This is A inverse. A is 2, 1, 1, 1. When we're going to multiply, when we multiply row and column, remember, one times 2 is 2. This row and this column. Negative 1 times 1 is negative 1. Then the second element, 1 times 1 is 1. Row, column, negative 1 times 1 is negative 1. Row, column, negative 1 times 2 is negative 2. 2 times 1 is positive 2. Row, column, negative 1 times 1 is negative 1. Column, 2 times 1 is positive 2. Now when we do this, you see 2 minus 1 is 1, 1 minus 1, 0. This is 0, and negative 1 plus 2 is 1. So this is the identity matrix. Therefore, our answer is good. Our answer is correct. Right? Okay, I'm gonna erase this. Next, it explains some matrix properties. You may read this. This is in page 631. If I write the same thing here. Under addition, it is commutative. Erase this. Properties of matrix. Matrices, their addition is commutative, means under additions A plus B is same as B plus A. Under multiplication, we do it in this way. I write this here and multiplication over here. A plus B equal to B plus A. It is commutative, but under multiplication it is not commutative, means AB not equal to BA. Right? Under addition, A plus B plus C is same as A plus B plus C. It is same with multiplication. AB times C is same as A times BC. Means they both associative. A plus C equal to A. Remember what C? C is the zero matrix. Under multiplication, when we multiply matrix with its identity matrix, it won't change. When we add zero matrix to the matrix, it won't change. When we multiply the matrix with its identity matrix, it will not change. Alright, and there are two additional properties for multiplication. It is distributivity. You cannot talk about distributivity against addition, because it is distribution means multiplying. AB plus AC, this is the same thing. B plus C times D BD plus CD. A times KB KAB here K is a scalar. This looks like different. A times KB equal to, we can take K out, K times AB. What else? Okay, AI, the last thing we did, AI times IA. AI equal to IA equal to A, and A inverse A equal to A inverse equal to I. Right? Those are the properties. Okay, now so I describe finding the inverse matrix A inverse for 2 by 2 matrix. That is different for 3 by 3 or any other matrix. For 2 by 2 we can easily find the inverse matrix in that way, but for other matrices we're going to discuss that in next section. I mean appendix A3. right? Now let's look at system of equation. I'm gonna erase this. Use a different marker. Systems. And matrices. And let's see with matrices. Using using matrices. Solving system of equations. Solving. Alright, now let's see how it works. Now let's leave this topic for a moment and let's look at this example. 3, 5, 2, 7, too close. 3, 5, 2, 7, XY. So when we multiply this, this is what? This is 2 by 2. This is 2 by 1. What we should get? We should get 2 by the number in the middle. We can forget about that and we get 2 by 1 matrix. Means only it's a column vector. Right. Now we can do an equation. Now this is a matrix equation. Let's see what the meaning of this, right? We know how to do multiplication for column, row, column, right? Okay, this is 3x plus 5y here 2x 7y, right? This is equal to, this is given 6, 9, right? Now if these two matrices are equal, from the first day's lesson A1, we can say their corresponding elements are the same. First element, second element, first element, second element. Okay, therefore we can say 3x plus 5y equal to 6 and 2x plus 7y equal to 9. Right? Is this look familiar to you? Yes, right? Now these two are system of equations, right? You know how to solve this. We can use addition method or elimination method to find x and y. Now the important thing is not that when this is given, write the system of equation is not the aim. Our goal is, given this, convert that into this. What's our goal? Our goal is, given this, convert into this form, right? And solve it using properties of matrices, right? Okay, let's get a simple example. So what we're gonna do, we're going to get a system of equation and convert that into matrix form. We can do that because we saw when we have this type of matrix equation, when we do multiplication, we end up getting system of equations. That means when we have system of equations, we can write it in the matrix form. Now look at this. How to write this? We can see it very easily. We see, if you just get coefficients of this x and y, 3, 5, 2, 7, 3, 5, 2, 7 comes there, x and y comes in a column vector, other side of the matrix comes as it is, 6, 9 comes there. Get it? Therefore, if we get this system of equations, we can directly write this one, right? Let's see an example. This is again from the book. This is in page 633. 2x plus y equal to 21. X plus y equal to -4. Right? What's the question? Solve the system using matrices. Right? Now first we want to convert this system into matrix form. We learned that with the previous example it is simple. We write the matrix with coefficients 2, 1, 1, 1, 2, 1, 1, 1. That's the coefficient matrix. Here we get x, y. On the other side we get same two numbers here in a column vector, 21, -4. Right? So we converted this into matrix form. Now this is like, this is in the form A. This, if you take this as A, and if you take this as capital X equal to, I'm gonna use the same letter they use, C. Okay, this, let's take this as C. We take this as C because this is a constant. This vector is constant. It has all constants in it, right? This is a matrix. Now we want to solve this. Now let me put it in this way. Let's multiply both sides by A inverse, which is the inverse. Now this times this. What we're going to do, we take this, we multiply both sides by A inverse. As far as you multiply both sides by the same thing, it's the same. That's the property of equation like a balance, as we discussed, right? A inverse, we multiply both sides by now. Once we do that, we can get these two together. Now if you consider these two together, you get I times X equal to A inverse C. I is the identity matrix. I times X is same as X equal to, other side we get A inverse C, right? Once we get X, we are done. We have X, other side we have constant vector. This X means this here, this X means X comma Y. We use a different color. This means a column vector XY. Here we get two numbers, then we say X is this and Y is whatever the number here, this, right? So what we have to find, we want to find inverse of A, and we have to multiply that with C, right? Let's see we can do this. I'm gonna erase this. A is this. A is what? A is 2 1 1 1. In fact, we found the inverse of this matrix before. I'm using the result. A inverse we found. For this A inverse we found as, I write it from here, A 1 negative 1 negative 1 2. This one we found. Okay. This matrix we found before. Right. Now to get x, all we have to do is, therefore x equal to A inverse C, which is 1, negative 1, negative 1, 2. This is A inverse C is 21, negative 4. This is 2 by 2, 2 by 2, this is 2 by 1. Same number in middle, so we can do it. The resultant should be 2 by 1, right? Now let's multiply this and this. Write it here. 1 times 21 use different color. This is 21, negative 1 times negative 4 is positive 4. Negative 1 times 21 is negative 21. 2 times negative 4 is negative 8. This is equal to -25 and negative 29. Right? So xy, this x is what? This is xy. Right? Now xy equal to 25, 9. I'm gonna write that here. Negative 29. I copied it from here. xy equal to 25, negative 29. Therefore we can say x equal to 25 and y equal to negative 29. Alright, that's our final answer. Right? Now in short, we had this system of equation without doing the regular addition method or elimination. We use matrices to do this. We form the coefficient matrix and the column vector equal to another column vector with these two, and we solve for x. We get answer using A inverse times, this is A inverse times that column vector. We get this, right? When the matrices are too big, this would be little bit tough, but still we can do it. Finding A inverse is different, so I'm going to discuss that in next section, means appendix 3. Let's see what else is remaining here. Okay, let's look at a different type of a question. I'm gonna erase this again. I'm gonna do a system of equation. Two x plus y equal to 6, 4x plus 2y equal to 9. Now if you look at this, this has no two equations, though you see two equations. You get means the left side, if you multiply left side by 2, you get the same thing here, only right side is different, which means what? These two are two different lines which are parallel, therefore no solution, right? There are two special cases with lines, if you remember. The other thing is this, 2x plus y equal to 6 and 4x plus 2y equal to 12. Now here in this case, right side also same if you multiply by 2, right? This means two lines are overlapped. Here in this case no solution, here many solutions. Okay, now how we recognize this, we're going to discuss about this type of systems in next section. Now if you do the matrix form, we get 2 1 4 2 xy equal to 6 9. It's good to practice how to convert this system of equation into matrix form. It is we can do it. Practice this, then it will be not too hard, right? Now now this is like ax equal to c, x should be a inverse c, x is a inverse c, right? A times x, put a dot here. Okay, now for this, how we find A inverse? A inverse is 1 over det A. You interchange these two, we get the same thing. we change the sign of these two, negative 4 1. What's the determinant of a? 1 over, downwards it's positive, 4, upward it is negative. 4 times 1 is 4, minus 4. Here we get 2 1, negative 4 2. Now you see this is 0. This here we get 1 over 0 times this, right? Whatever this matrix, anything over 0 is undefined. Undefined. Therefore inverse matrix does not exist. A inverse does not exist, right? A inverse does not exist means we call this is a singular matrix, right? That means this has no solutions, right? This is 0 times this, undefined. This means A is a singular matrix. Therefore system has no solutions, right? So this is our final answer. Determinant is undefined, therefore A inverse matrix does not exist. That means A is a singular matrix. Therefore the given system this has no solutions, right? That's our answer to this system, right? Now transpose of a matrix. This thing is not much using in these exercises, but I'm just tell you what it is. Transpose. I'm gonna erase this. To find the transpose of a matrix, you simply interchange rows and columns. Now I give you this example. Transpose, we write this as A simple T transpose. A simple T transpose of a matrix. Example 5, 7, 9. Okay, then A transpose is equal to 1, 3, 4, 5, 7, 9. Right? Transpose is this. Right? That's all about transpose. Okay. Now I also want to show you how to enter a matrix. Last time I showed you how to enter a matrix, that is which is in the book. I'm going to show you another method. I try to move it here. I believe you can see this. I'm showing my calculator now. This is what you have to do. Go to data matrix. Data matrix editor. Here. I go to data matrix editor and enter. It's as current, open, new, open a new one. Then do these changes. On the first line it shows data. Click right arrow and select matrix. Go to the second option. I think, yeah, I'm turning it because I cannot see it when I'm showing to the camera. Matrix. I selected matrix, enter. Then don't change the second one, leave it in main. Then it has variable. In variable, give a name to that. I think I have A, B, C, D. Let me give a different letter, say E. You may type A there. I'm gonna do you know now how to type letters. Use alpha key and the letter A, B, C, D, E. Alright, I enter E there. Rows, the next two lines are number of rows and columns. I'm trying to show you. I don't know if it is, you can see that there is a glare too. Okay, here. Right, so I'm gonna enter number of rows and columns. Say if you wanna enter 2 by 3 or 3 by 3, enter number of rows and columns. I'm gonna enter 2 by 3, and once you hit enter, twice variable or flash I use, that means I use that letter for some variable. I have to change this letter. I change it to different letters, say F, right? Then I hit enter. Give me a second, let me enter this letter and I will show you. Two by three. Okay. I enter 2 by 3 and enter. Once I do that, you see 2 by 3 matrix I got here with all zeros. Now I can change these to any numbers. I'm entering random numbers 1, 2, 5, 7, 3, 6. I enter that. Now that's my matrix. Then I quit here. Second quit. I go to home to see if I get that. See, I have these A, B, C, D letters for different purposes. Let me enter this one. I type F here, alpha F, and enter. Once I enter this, I got the matrix I entered, right? I think that would be a easier method, I find. Okay, if you like that, you may enter in that way or the way I told you last time, right? Now anyway, now you know how to do enter matrix. You know now 2 ways to do it. Now if you want to multiply this, what you learned today, I already entered 2 matrices. Okay, let me show you. I type A, matrix A. I don't know if you can see this. I try to show you my best. You see 2 by 2 matrix here. Now I enter B, alpha B. I got 3 by 3 matrix. I entered this before, right? I entered this before, 3 by 3 matrix. Now 2 by 2 times 3 by 3. Can we do that multiplication? No, right? 2 by 2 times 3 by 3. Same number not come to the middle. Therefore, we cannot do that multiplication. Let's see what calculator will say us. I'm gonna type alpha A multiply by alpha B. So what we expect, it should give us an error message. It's clear coming. I don't know where it's coming. Okay, now you can see it. I enter a times b, I enter, you see it gives us an error message. Dimension, it's the error message dimension, right? So we know it, right? Now let's do another one. Escape this. I show you my a was 2 by 2. You saw that. I think I enter another matrix at D. D is 2 by 3. A was 2 by 2. This is the matrix D. At last you will see that it is 2 by 3. We can do that multiplication. Okay, let me ask calculator to do that. Multiply matrix A. You simply type A times D times D. I type A times D, enter. Okay, I got answer, right? It gives me some numbers. Okay, this is a good angle to show, right? No glare, but I don't know if you can see it, right? You see some numbers there, 20, 31, 42, -3, 0, 3. Anyway, these are sensible numbers. That means calculator did the multiplication between two matrices, right? So that's all I wanted to show you today. I'm gonna do more systems of equations with more equations, and also no solution systems, and infinite number of systems, infinite systems with infinite number of answers, solutions, right? With the next video, right? Take care and stay safe, guys, right?